Okay, fifth graders, today we are doing Module 2, Lesson 7. And as you can tell by the learning goal, we're doing more of the same stuff, right? It says again in the learning goal, I can explain how the partial products, we know what that means from last week, of an area model, we definitely know what that means from last week, and we're going to see how they are related to the standard algorithm. So it's going to be very similar to when we were drawing arrows to connect the partial products of the area model to the standard algorithm, okay? But it's a little bit more complex today, and I will show you why. Today's directions tell us to draw an area model. Okay, that's step 1. Then we solve using the standard algorithm. Okay, so far it's the same. Then we use arrows to match the partial products from the area model to the partial products in the algorithm. We've followed these directions before. Yes? Okay, the first part is to draw an area model. So if our question is 524 times 136, an area model, as we know, always starts with a rectangle. Now rectangles that are big are easier because, as we know, we're going to have to write numbers inside them. Yes? So, if we can draw it nice and big, then we'll be able to fit all of our numbers. Okay, our first factor is 524. How many parts can I split that up into to make my area model? Nadav? Okay, what's my first part?
500.
500. What's my second part?
20.
20. What's my last part?
4.
Good. I'm going to divide my rectangle into 3 sections going up and down. My second factor is 136. How many parts should I split that one up into? Sushant?
3.
What are my 3 parts? 100. 30. Good. So all together on my area model, how many partial products will I first find? Mira? 9 partial products. Very good. Okay, let's find the area of this first section. How do I find the area of that section outlined in red? I have to do the length times the width. So Ikash, what is the length times the width?
The length times the width is 500 times 100.
100 times 500. Good. So I can think to myself, 1 times 5 is 5. And then I have 4 factors of 10. Yes? Okay. What is the length right here that I'm drawing up and down, making it very thick? 100. Good. What is the width? 20. So how do I find the area of this second segment? 100 times 20. 1 times 2 we know is 2, and then there are 3 factors of 10. So 100 times 20 is 2,000. Okay, what is the length and the width of this last section? 100 times 4, which is? 400. Good. Okay, let's move on to the next part. What is the blue length there? 30. And then what is this width?
500.
So to find this area, we do the length times width, or 30 times 500. 3 times 5 is 15. And then how many factors of 10 do we have?
3.
Good. So it's 15,000. This next section is 30 times 20, right? Good. So 3 times 2 is 6. And then we have 2 factors of 10, so it's 600. Of course, the last one is 30 times 4. We know that 3 times 4 is 12, and then there's 1 factor of 10. Yes? Good. Okay, last but not least, this is 6 times
500.
Good. Okay, here's an easy place to make a silly mistake. Watch. I know that 6 times 5 is 30, and then there are 2 factors of 10, so I need to have 2 zeros. Is that correct?
No.
How many factors of 10 did I account for in my answer?
2.
By writing 300, how many factors of 10 did I account for? Only 1. Because it's easy to get confused because there's already a 0 in 30. So I need to make sure I put both factors of 10. Good. My next one is 6 times 20, which of course is 120. And then my last one is 6 times 4. Easy math facts. It is
24.
Good. Okay, so now I have 9 different partial products. Okay. I want to now do my standard algorithm. Okay, when I do my standard algorithm, I'm going to first do 524 times 6. Do you guys agree? So 6 times 4 is?
20.
24. 6 times 2 is 12 plus 2, 14. 6 times 5 is plus 1. Okay. 3,144. Where is that partial product on my area model? Turn and tell your partner. As we just said, we just did 524 times 6, or 524 times 6. So that first partial product is really the area of this bottom slice. Do you guys agree? Right? Because again, it's 524 times 6. So in order to get 3,144, we have to add 3,120 and 24. What's 3,000 plus 120 plus 24? 3,144. So there's that partial product. Okay. Well, if we take that reasoning, we know that the next step we would do is 524 times 30. Do you guys agree? In our standard algorithm, right? So again, that's 524 times 30. So it's really this slice. So before we even do the multiplication, what do you think that partial product will be? It'll be 15,000 plus 600 plus 120. 15,720. You can do that in your head, huh? Because you know that 600 plus 120 is 720. You add that to 15,000. Okay, let's check using our standard algorithm. We know that we're on step 2. We're multiplying by 30, so we're going to add one placeholder 0. What's 3 times 4?
12.
Okay. What's 3 times 6? 3 times 2 is 6 plus 1, which is 7. And then 3 times 5 is 15. So what's our partial product there? 15,720. Draw an arrow to show that it's the same. Okay. Next in our standard algorithm, we're doing 524 times what? 100. Times 1? 100. 524 times 100. So we're really finding the area of this top slice here. We have 50,000 plus 2,000. What's that? 52,000 plus 400. So what's the partial product do you think is going to be?
52,400.
Okay, because we added 50,000 plus 2,000 plus 400. So we had 2 placeholder zeros because we're working in the hundreds. And then we have 1 times 524, which is 524. Did we get the same partial product? Yes, we did. Some of you on your weekly check-in did all this multiplication correct. And then you stopped here. You said, I'm done. I have my 3 partial products. What's the question asking us to find? 524 times 136. So which of those numbers is the final product of 524 times 136?
None.
None of them, because the whole product is 524 times 136. So it's the whole rectangle. Do you guys agree?
Yeah.
So that's why at the end of the standard algorithm, we always have to add the partial products. Right, Sakina? Okay, good. So how many ones do we have altogether?
4.
How many tens do we have altogether?
6.
How many hundreds?
12.
Okay. How many thousands?
11.
Okay. How many 10,000s?
7.
So the final product is 71,264. If I were to add up this plus this, it's kind of messy now, plus this, would I have the same answer?
Yeah.
That's the red slice plus the blue slice plus the yellow slice. That's how the standard algorithm works. Does that make sense?